Well, we have something new for you tonight. I'm sitting here on my laptop. I don't have access to my document camera because I'm in the hospital still, hoping to get out tomorrow, Sunday night right now, 10:15. But anyway, I would like to get some feedback from you guys, how you like the PowerPoints. I like this particular one, but I want to know how you like the videos of the PowerPoints and if they help you more or less or good and bad points, whatever. So I'll hopefully be able to see you on Tuesday, Wednesday this week. And these are the ones you're supposed to be watching before, prior to those days, prior to coming to class Tuesday or Wednesday, depending on what period I have you. And so let's go ahead and get started. Obviously, we're graphing sine and cosine functions. And we will get to, in the next video, the reciprocal functions as well as the tangent. And I'm going to flip through these first few slides pretty quickly because this is actually not the way I would encourage you to graph these functions. We've already talked about how to graph the sine function. And guys, if you forget everything else, do not forget that you can always plot points. Pick an x value, plug it in, get the y, and you know the sine and cosine functions are nice and undulating. They'll repeat themselves every 2 pi radians, the sine of x anyway, and so forth. So we have the sine of x. It'll repeat and go on forever. A domain of all real numbers. A range from -1 to 1, including -1 and 1. And you get the details here. We've already talked about these. X-intercepts. The max and mins occur. You can see down there, number 6. So periodic, period of 2 pi. Now, transformations of the sine functions. Now, I talked about that in the first video, the one you should have watched before Monday. And this particular sine function, you should already have an idea. 3 sine x, you should already know that it's the same exact shape of the sine of x, with the exception of it has an amplitude of 3. So from 0 it goes up to 3 and down to -3. There's the sine of x. You just take it and stretch it out. Okay, and whenever I have you draw a sine or cosine or any trig function, I really only need you to draw it over one period. And if you want to extend it, fine, but one period is also totally fine. Now, this particular function, you've got a negative sign outside the sign. The first thing I would do is take 2 pi and divide it by 2 and to get the period. So first we start with sine x. This is not actually the order I would normally do this, and I'm going to show you the end result. And then and notice down along the x-axis, we've got one period of this sine function goes from 0 to pi. So pi is the period because it's 2 pi divided by 2. Notice up here, the period is 2 pi. So we've basically, they look exactly the same, but we've just squeezed this graph up here, the second graph, in half because we cut the period in half. But again, this is our end result. I'm going to show you in a later slide how to do that a little bit easier and not have to write all those numbers down. Again, just to repeat, we've got this cosine function here, domain of all real numbers. The cosine and the sine are exactly the same, just shifted over. They're both what we call sinusoidal because they're shaped like a sine curve. And we can do the same thing with the cosine. Again, I'm just going to flip through here. I'll pause a little bit if you wanted to take a look, and if you wanted to pause longer, go ahead. I'm not going to walk you through these. Okay, sinusoidal, as I said, both shaped exactly the same, shifted over. And notice the cosine of x is the one in, I guess I'll call it purple, and then the one in blue is cosine of x minus pi over 2, which is exactly what the sine of x is. And there you see it. Okay. So that's kind of cool. Cosine and sine are exactly the same, just shifted over. And so there you go. You have a relationship between sine and cosine. Seeing the concepts, sine x, cosine of x minus 2, you see, plot them both on your calculator and you see one graph. Okay, amplitude and period. Amplitude is 2. Period is 2 pi. Okay, so really exciting stuff here. Now notice in this bottom graph, we've got 2 pi divided by 3, which is the period. Okay, so 2 pi divided by the number in front of the x, coefficient. You start here, and one full period until you get to 2 pi over 3. And I'm going to show you a couple things here on how to draw those curves in the simplest way possible. The main thing that you need to know, and I still can't remember what that W is, I just call it W. Every time I do that. Okay, so I call it W because I can't remember what the Greek name for that letter is. But the A, the absolute value of the number in front of the sine or the cosine, is always going to be the amplitude. And the period, I could care less if you call it T. There's 2 pi over W, and those are the two main things I want you to be focusing on right now. Amplitude here, if you notice, is 4, and the period is 2 pi over 3. Okay? So these are two very important parts of the sine cosine functions. Now, this is the key. Please really focus on this. Graphing using, what do we say, using key points. This is the most effective way to graph these. This is like a piece of cake when you understand it. Okay, you always start with sine x, cosine x. They look exactly the same. They will always look the same no matter what. So don't let anyone tell you any different. You can notice here the dots. You see 5 dots on each graph. Whenever you graph sine, cosine, tangent, secant, any of those, just pick 5 points and draw a nice smooth curve between the 5 points, and you will be set. Okay? Cosine x, pause the video if you want. You already know how to find these values. Okay? So, using key points, the first thing we're going to do is find the amplitude and find the period. Okay? Now, period is 2 pi over 2. Draw your graph. Okay? And then you're going to draw your graph, you're going to divide the interval, the period really, into 4 subintervals of the same length. Okay? This looks more confusing than it should. What I would like you to do is draw the graph. Okay? And then notice on the x-axis, we determined that the period was pi radians. Okay? So I'm going to kind of walk you backwards. I hate this thing. Okay, I'm going to walk you backwards here. We got pi radians. Gotta be careful. I'm on the laptop, and every time I hit I'm scrolling or moving the mouse around, it jumps to the next slide, so I apologize. The first thing I would do, find the period and mark it right there. Period is pi. Okay, so basically all your graphs are going to look the same, and that's okay. I don't mind. Pi over 2, you cut it in half. You cut the pi over 2 in half, and then find the halfway point between the pi over 2 and the pi. Okay, and so you've divided your period into 1, 2, 3, 4 equal sections. Okay, subsections. And then all you have to do is plug in 0. Okay, but you also want to, you don't even need to do that. You don't even need to actually find the amplitude. You do eventually, but because if you plug in 0, you get 4. When you plug in pi over 4, you get 0. When you plug in pi over 2, you get negative 4. Plug in 3 pi over 4, you get 0. And you plug pi in, and you get 4. And you just connect the dots. It's as simple as that. Okay, that's it. And if you want to extend it, fine. But I really only need you to do that. Right there. Graph that using key points. Okay? Now, I would encourage you to, you can copy these down if you want, but the main thing is you understand what you're writing down. Okay? So make sure you understand. So I would challenge you to do this particular problem the same way you did the last one without even looking. Okay? And using key points. Now I'm going to go all the way to the very end because that's where I would start. I would not start doing this stuff. I would go right to, where would I go? All right to there? No, I wouldn't go to there. I think. Oh, the period is 8. Yeah, I would do that. So the period is 8, and where are we here? 2 pi divided by pi over 4, and you get 8. So I would mark 8 down on my graph, on my x-axis. Guys, 8 radians is just fine. Okay? Don't be freaked out because you have 8 radians, there's no pi in there. just mark an 8 down. You know, and this is even better because half of 8 is 4, half of 4 is 2, halfway between 4 and 8 is 6. So then, what do? You plug in 0, because that's the beginning of your interval. Okay, the beginning of your period. Remember, the period is 8, 0 to 8. So you plug in 0, and what do you get? You get negative 3. So you put a dot. How awesome is that? You plug in 2, the cosine of pi over 4 times 2. That's 2 pi over 4. Okay, well, 2 pi over 4, cosine of 2 pi over 4 is cosine of pi over 2. Cosine of pi over 2 is 0. Negative 3 times 0 is 0. That's why we get a 0 there. And when you plug in 4, you let x equal 4, and you get pi over 4 times 4, which is pi. Cosine of pi is negative 1. Negative 1 times 3 is 3. We have a dot. They all work the same way. Plug in a 6, you get 0. Plug in an 8, you get negative 3. And then you just connect the dots with a nice, smooth, sinusoidal curve. How beautiful is that? Piece of cake, right? All right. Same thing right here. You've got, encourage you to try it on your own. Amplitude is 5. Yeah, we'll see that. Period, that's the big deal right there. The period is 2 pi over 3. Okay. Well, if the period is 2 pi over 3, you know, I don't even do this part. I don't go 2 pi over 3 divided by 4 is pi over 6. If you like that, go ahead. And but again, I would start right here. I'd make my y-axis, I'd make my x-axis, and I'd mark, okay, maybe mark 5 up there. That's fine, because you know you're going to get up that high. And then you go 2 pi over 3, and you just write it down. 2 pi over 3, and then you go, well, what's half of 2 pi over 3? Well, that's pi over 3. Well, half of that is pi over 6. And then you have to find the average of these two. So sometimes this is a little tricky, like this is the trickiest one to find, the halfway point between pi over 3 and 2 pi over 3. Well, you can add them up and divide by 2, and you end up getting pi over 2. Or you could draw a unit circle. If you draw a unit circle, you could mark the pi over 3 and 2 pi over 3, and you'd see that halfway in between is pi over 2. So again, you take the beginning, where's my mouse? Take the beginning of your period, which is always going to start at 0. Okay, now this is until you start doing a shifting left or right, but either way, it's fine. Always start at 0 and mark the points first before you even do shift left or right. We'll get to that in a later video. Okay, so anyway, gosh, I'm already at 13 minutes. 0, you plug in 0, you get 0. Same with the pi over 3 and 2 pi over 3. You plug in your pi over 6, and look, pi over 6. You plug it into the original function. How do you get the y? Well, you plug in the x. Pi over 6, 3 pi over 6 is pi over 2. Sine of pi over 2 is 1. 5 times 1 is 5. And so you get pi over 6 comma 5. And that's where you get that ordered pair. Plot the dot, connect all 5 dots, and that's what you need to keep in mind. You're always going to plot 5 points, okay, when you do these videos. Find an equation for a sinusoidal graph. I think we'll take care of that later on, okay? And so we'll just back up to this one, and I'm just going to do one more video tonight, and we'll incorporate the reciprocal functions, and then then you'll have one more, and that's a crazy video. I did that one first, and that's a mess, sorry. But anyway, good luck, and keep in mind this last part of the video, if you didn't get it, I would encourage you to go back, try to graph each of those functions, but when you can understand the 5 key point method for graphing these functions, that is the best way, and you'll be really successful being able to do that. See you next time.